In this video, we're going to talk about the topic of section 11.8, which discusses this object referred to as power series. So from one point of view, I suppose power series are very related to polynomials. Now, you're aware of what a polynomial is. This is just a function, which is a collection of coefficients with successive powers of x separated by plus signs, right? So we have a constant term, a degree 1 term, a degree 2 term, out to a degree n term. So if we're looking for sort of an example of a polynomial, you've seen these things many times before. What about like 4 plus 5x squared minus 7x to the third plus 11x to the eighth? There's an example of a polynomial. So it's got a constant term, it's got a degree 1 term, a degree 2 term, all the way up to a degree 8 term. In particular, I suppose, the degree 1 term has coefficient of 0, the degree 2 term has coefficient of 5, the degree 3 term has coefficient of minus 7. All of the terms between degree 4 and degree 7 have coefficient of 0, and the degree 8 term has coefficient of 11. So here's a polynomial, and in fact, if we're being sort of real precise here, we could say this is a polynomial of degree 8, because, well, the highest non-zero coefficient of this polynomial is 8. Now, how do we get from the polynomial world to the power series world? Well, whereas a polynomial eventually stops at degree whatever it stops at, a power series proceeds to infinity in power. So whereas a polynomial is of degree 8, let's say, in this case, or degree 4, if your highest non-zero term was a degree 4 coefficient, a power series is essentially going to be a polynomial of degree infinity. So it's going to be a polynomial of sort of never-ending degree. And in fact, I should be very clear here. So this power series, this polynomial of infinite degree, is actually a general form of a power series that is in fact centered at x equals 0. Now I need to be clear about what I mean for a power series to be centered at a particular x. So the center of a power series is a value that you could substitute in for x, for which only the constant term c0 remains. So if we could, looking back up here at this polynomial, I claim there's a value you could plug in for x to where only the c0 term would remain, to where all other terms would get wiped out. And in fact, if you think about this, what could you plug in for x that would wipe out this c1x term regardless? Well, the thing you could plug in for x would be 0, right? 0 would multiply by c1 and wipe out that degree 1 term. In fact, 0 could plug in for x squared and wipe out that c2 term. 0 plugging in for x cubed would wipe out that x cubed term. And in fact, all the terms of degree 1 and higher would get wiped out if x was equal to 0. That is precisely what the center of a power series is. There will be one number which you could substitute in for x. It would be a value which will only leave the constant term c0 remaining. So take this example that we looked at, right? If you plug in 0 for x, essentially all of these terms of degree larger than the constant term are gone. They all get wiped out. And what's left? Just c0. So that's why we say that this polynomial, or rather this power series, is centered at x equals 0. The center is the value you can plug in, which only leaves the constant term remaining. So what about this power series below? This power series below here, we've got a power series g. G is c0 plus c1 times the quantity x minus 5 plus c2 times the quantity x minus 5 squared, and so on. Now, as we look at this power series, I claim 0 is not the center of this power series, because if we plug in x equals 0, you won't wipe out the degree 1 term. In fact, if you plug in x equals 0, you'll just get minus 5 times the c1. Well, that doesn't wipe out c1, does it? In fact, it wouldn't wipe out c2 either, because if you plugged in x equals 0, you'd get 25 c2, which doesn't wipe out the c2 term. So now, if we want to find the center of this power series, we want to find the value for x that we could plug in that would wipe out C1 and C2 and C3. And if you think about it, what could you plug in here? Well, if we need to wipe out this x minus 5 times C1, what if we let x equal 5? Wouldn't that wipe it out? Because then we just have C1 times 0. And in fact, if you plugged 5 in for all of these x's, then in fact you would wipe out all of the terms of degree greater than 1 and greater, I should say. And so, in fact, what you end up with when you plug in 5 to g is just the constant term. Hence, 5 is the center of this power series. Because remember, the center of a power series is just the value you can plug in for x that leaves only the constant term remaining. So, whereas above we have a power series centered at 0, plug in 0, it wipes out all the terms of degree greater than 0. Down below here, we have a power series of of center 5, because you can plug in 5 and wipe out all the terms of degree greater than 0. Okay, so to see this sort of in action, here's a collection of power series, and we want to find the center. And in fact, we want to find a general form of the coefficient for each. The coefficient for each is just going to be the coefficient that's parked in front of that x minus a to the nth term. So when we talk about the coefficient, the general form of the coefficient, that's just the Cn. It's essentially just the constant that's in front of each of your terms of a particular degree. And if you look at this power series expanded out here, note, by the way, this is just in sigma notation. So if you let n equal 0 first off, you'll just get C0, because the number here, x minus a to the 0 power, would just be 1. Anything to the 0 power is 1. Plug in n equals 1, you'll get the C1 x minus a, C2 x minus a squared, and so on. Okay, so now, essentially, what we've observed is that the term in front of the power of x is our general coefficient, and the power of x itself actually yields the center here, because the center is going to be a. Plug in a for x, and note you would get a minus a equals 0 and wipe out all of those terms of positive power. Plug in a for x, you would wipe out all of these terms, which means the center is going to be x equals a. So now we want to look at these power series that are written over here, and we want to identify not only the center, but also the general form of the coefficient for each. So looking at this polynomial here, we want to identify the center. We want to identify the value for x, which is going to leave only the constant term remaining. And the value for x here, you can see what it has to be. The center has to be x equals 4. So in this case, the center, x equals 4. And now we also need the general form for the coefficients. Well, the general form for the coefficient is just going to be what is written in front of the power of x. Well, what's written in front of the power of x here? Cn is just n over 3 to the n. So there is our general form of our coefficient, and there is our center. Okay, so looking at our next example, in our next example, we've got, well, actually, basically the same series, don't we? It doesn't look exactly the same on the surface, but if you think of what is written above as just that x to the 4 quantity over n times, over 1 rather, if you think of that as a fraction, you can see quite clearly how these two things, when you multiply the fractions, would be identical. And so what we have written here basically looks a lot like what was written previously, but just with our power of x melded into that fraction. So be it. You could just rewrite this as n over 3 to the n, x minus 4 to the n. Basically take that power of x out and set it to the right, because it would read exactly the same as what was previously written in terms of its value. And so if we process this all, note, in fact, since this is the exact same series, it has the exact same center, and it has the exact same general term. But I did this because it demonstrates a tactic that you can apply to then any power series if you're trying to identify the center and identify the general form of the coefficient. So look at this series here. If we take our coefficient n squared over n cubed plus 5n minus 2, and we separate it from the power of x, x plus 11 to the n, what we then have is we have our general coefficient separated from our power of x. And that allows us to see more clearly what the center is and what the general coefficient is. So the center is what value for x we would have to plug in so that all the terms of degree 1 and higher would get wiped out, and you'd only be left with the constant term. Well, the value for x here, our center, has to be what? If you plug in an x here to wipe out this 11, the center has to be minus 11. So the center of this power series is minus 11. And what is the general form of its coefficient? The general form of its coefficient is just n squared over n cubed plus 5n minus 2. There we go. So it's kind of just a plucking of that coefficient in front of the x to grab the general form of the coefficient, and looking at the center that lies behind, we just have to look at what would sort of zero out those factors of x. So looking at this last example, we can take this and polish off our little exercise here. So what is this going to be? 1 over 5 to the n ln n with the x plus 2 to the n written after it. Now, of course, this is a sum from n equals 0 to infinity, but so be it. Ultimately, all we're concerned about here with our power series is noting its center and noting the general form of the coefficient. Well, the center is the value of x we can plug in that will wipe away all the terms of degree 1 and higher, which you can see what that x is here. That x has got to be minus 2. So the center of this power series is minus 2. And what's the general form of the coefficient? Well, here it's, and always in fact, it's just the constant that's in front of your power of x. So here that is just 1 over 5 to the n ln n. And hopefully you can see from these examples that if you are trying to identify the center and the general form of the coefficient for a power series, it's actually not that hard. The general form of the coefficient is just the coefficient that's parked in front of that power of x. And the center is the value for x that you have to plug into that power of x in order to make that power of x 0. And so, there you have it. You know what a power series is. It's a polynomial that is of infinite degree, in effect. There is a center, a value for x, that wipes away all the terms greater than degree 0. And the general form of the coefficient is just that coefficient that's parked in front of the power of x.